Hey everybody, welcome to wasmCloud Wednesday, September the 3rd. We are, oh my gosh, in our last month of quarter three. But do not despair. We've got some pretty nice updates regarding some of the bigger ticket items on this roadmap. I know that last week, all right, good job, note taker bot. I know that last week we talked a little bit about one of the tickets that's on the roadmap, which is, let me go ahead and share my screen. We talked about this issue, which is in the research column around configuring a Wasm Cloud host with shared capability providers. I know Aditya kind of came in and did a little bit of a presentation and led the discussion, which was really nice just to call out some of the things that we still need to figure out here, which is okay. You know, some of the things in the research column, we are going to need, like, we ultimately just need time to pick it up off the backlog and get it well scoped. So, that was last week. This week, I threw two items on the agenda. I'm actually going to bow out, sad, of doing a demo of the in-process component-to-component calls. I actually have done a demo of this before, so it super works, I promise, or whatever. But we'll just leave this mostly to discussion for these two tickets, because I think a back and forth would be a little bit better. And I didn't get it added to the agenda, but Bailey actually has a demo that we'll stick on at the end here for wash plugin completions with the CLI, which is really cool. So looking at quarter three roadmap, if we can just maybe poke around at what we have in progress, completed. I know that Wash hasn't been officially, the updated Wash that we've been working on. I know that hasn't been officially released to replace what Wash is now. I think that's okay. I've marked this RFC for Pluginify Wash completed because it's something that we, well, did. Now, some of the other ones that are in progress that you may be anxious to hear a little progress around are first, in process component to component calls. This is one of the things that we got as a feature request very often. And the idea is if two components are running on the same host, like they are executing in the same WASM time engine, if one of the components has an export and the other component has an import and they're linked to each other, why do we send that invocation out over wRPC over nets? Now, there are good, instead of just calling it directly. Now, there are good reasons to do this. One of the reasons that we stuck with for the longest time is that if you keep this principle, like that everything goes over this RPC layer, then yes, you may incur some local penalty for, the local network loopback is a really small amount. I mean, essentially negligible when you consider like the time that it may have taken for a request to get to this component. But that's only when you really do one. Now, the benefit of taking on that penalty all the time is that the behavior is very consistent. You're always going over the same code path. You don't have to think about oh, is this request going over nats? And so I need to think about how this will be load balanced, or oh, this is going to stay local. But still, this continues to be something that that comes up often. So looking at the feature request here, we brought this up in our roadmap planning for Q3. It would be really nice if instead of doing, couple hundred microsecond level calls, that components could call each other directly on the same host and do that in the single digit nanosecond level of latency, which is basically just the amount of time that it takes to take a value and make it cross over the component boundary to another component, or values, what have you. So one of the themes of this quarter's roadmap was intentional distributed networking. And so the idea is that we should be able to support this in-process component-to-component call when two components are running on the same host. If you want to have components talk to each other over a distributed network, then you could opt into wRPC explicitly, or maybe use an interface like WASI HTTP or WASI messaging to actually be able to control the semantics of that RPC call a little bit better. So enough talking of the background. This is actually work that's I was spiking on and implemented for Wash. Now you may be interested in why. Or what the purpose was. And one of the things that Wash does is it embeds the wasmCloud runtime crate. That's still the backbone essentially of how we are executing components here. But Wash Up and Wash Dev have things that make it difficult to manage the lifecycle when you're just trying to do a local development session. Having to download NATS, WATM, wasmCloud, any providers, any other components from a remote network is generally fine, but really frustrating when it comes to like orchestrating processes on Windows or making sure that one dev session isn't clobbering another. So with Wash Dev, I really tried to put forward this idea that it can be self-contained. You can develop on a component, you can develop a component, be able to extend with custom capabilities, custom implementations, but not use providers, not have an orchestration layer, and not go over NATs. So if there is no like RPC mechanism here, then we can't default to that. So in Wash Dev now, what we have is we have this helper function, which I just wanted to bring up because folks may be interested in taking a look at this a little bit more in depth. I'll send it in the chat as well. So sorry, this demo is just a code. We will initialize this component, and the linker here, if you're not familiar with like WASM time embedding, it's similar to how we link things in wasmCloud, like one component to the next on a specific interface. But this is literally creating basically the function callbacks for when a component calls an import, what gets executed on the host. So for things like WASI logging, what we do here is whenever you call the log function, that will execute this callback function in the host and will emit a tracing event with that level of verbosity. Same thing with wasmCloud. Nope. WASI config runtime. When you look up like a key, we're basically just reading that from a hash map, right? So this is how you can, well, this is how you embed, components in your program. And with wasmCloud, what we do today is really different. So we have this basically set of predetermined interfaces that we support: WASI blob store, WASI config, WASI key value, WASI logging, all this stuff. And then everything else, everything that we don't recognize as an import, we call this link item function. And what this does is it pretend links this item, pretend links it to wRPC, so that whenever you call an import, that's actually going to immediately send out a NATS message. And so this is how wasmCloud is able to support any custom interface. We don't know where it's going. We just assume that if you have called an import, that you have something on the other end of the distributed network that's listening to you. Now, we want to be more explicit about this. And so the approach that I took in Wash Dev is to explicitly define interfaces that we link. So WASI 0.2, because those are the standard interfaces, being able to access a file system, in theory, open a socket, access standard in, standard out. We have WASI logging, which I know is an interface. Sorry, WASI logging and WASI runtime config, which are two interfaces that are actually not out of draft proposal stages, but they're used pretty extensively in our examples. So I include them. WASI HTTP, because we like to use it. Oh, sorry, that's the wrong function. WASI HTTP, because HTTP is also part of 0.2. And then last but not least, this special function, link imports, plugin exports. Um, Another great one of my examples of superior naming and ability as an engineer. So this function does quite a lot of lifting, but what it allows you to do is register components for the dev process that export interfaces. This can be like WASI blob store, WASI key value. It can be your own, my org, my package interface. So if you have a component that exports this interface, you can link that component's export to your component's import. I should have drawn a diagram instead of waving like a crazy person, but we'll get there, right? So instead of doing what we do in wasmCloud, where we go over every single import that the component has and then push it out over wRPC, we iterate over every import that the component has that we don't satisfy with the runtime, like WASI 0.2 or WASI HTTP. And through some fun instantiation and looking up and matching and all that stuff, we are going to create a new callback function to call the other component's export when it's invoked. So I definitely need a diagram for this. Sorry for just waving. But basically what this means is we can create plugins like under the plugin directory blob store file system. This is what I've actually demoed before in this call, and what I hope to do now. I guess I could do it. I just don't have the local setup right. So this blob store file system component exports WASI blob store. So it implements the entire WASI blob store interface, and it imports, it's not pictured here, but it uses the WASI crate to import WASI file system. So it implements WASI blob store by storing things in a local file where the component has access. And this is really cool because at the runtime layer, we actually don't need to know anything about blob store at all. This component can implement it. You could do the same thing with WASI key value and then maybe push a message out on a socket or something and go to Redis. But the real key is that this is compiled to a component. And when you are developing an application like Blobby that imports WASI Blob Store, all of the Blob Store calls are actually going component to component to this Blob Store file system if you have it installed. So I wanted to give that spiel. So thanks everybody for listening to that. If you all already knew what was happening and all of that, but I wanted to give that spiel because this in-process component to component calls is something that I've been working on and ironing out the kinks for, and works quite well. Um, the parsing logic is a little unwieldy, right? Like there's quite a lot here of like iterating over what a component imports and what your other components export. But that is essentially going to be a key inclusion in the wasmCloud runtime crate, like the ability to link components together. So making this available in a generic way, I think is really key for the API surface here is hand in your Wasm time linker, hand in your component that you want to run, and then basically hand in, I have this dev plugin manager, but this other collection of components that has exports that you could call. So what this really looks like, and we'll talk about this more in a second. Oh yeah, there's all the lift and lower stuff too. It's all fun. What this really means is that if you make you, as in, a scheduler makes a decision to run two components on the same host, they can just talk to each other directly, which is awesome because we don't incur a network penalty. We have really predictable deployments. And you can always, of course, opt to do your distributed calls as well. It just seems a little wasteful if you have, say, this component that does logging for you, and you're calling it like 10 times within the same invocation. Why incur an extra penalty if you're just always scheduling them next to each other? Uh, yeah. So, just to maybe wrap up my thoughts on this one specifically, there's going to be more changes needed to make this work, I think, in a way that really feels nice in the Wasm Cloud perspective. Components calling components isn't always a frequent operation. But in whatever manifest config file format that we land on, we're going to want to have an easy way to intentionally put components on the same host and have them be able to talk to each other. So if folks are interested in seeing how that may work, I mean, I'm not doing anything really incredible. It's more just like transforming of resources, and you pass a value from one component to the next. But yeah, it's pretty cool. Special thanks to Roman on the wasmCloud, Wasm Time side, as always, for giving really awesome advice here, for giving me uh, essentially the blueprint for how this may for how this works, like how one component can call the next. I really used some of the code that Roman's written before to like we'll call heavily inspire, and not you made this, I made this. But yeah, big shout out to Roman for and all the predecessors who figured out the right way to do this, especially like lifting and lowering values. That part would have taken me 500 million years. So yeah, really what's next here is pulling this out of Wash and getting it into the runtime crate so that it's easily consumable by a wasmCloud, moving it with Wash and everything. Um, yeah, so pretty cool stuff. Do folks have any questions about this issue? Bailey, yes. Oh, I see one in the chat.
Redirect to the chat.
Yeah. So Masood, feel free to come off if you're here. Does this logic remain part of the runtime when wRPC interface implementations are taken out? Honestly, I just paused to see if you
Well,
wanted to.
that's also part of the plan or the bigger picture. So I'm wondering that, like, are we adding technical debt here, or we're kind of evolving the host implementation, toward, let's say, such a unified, and I'm air quoting,
Yep.
uh, you know, future.
Yeah, no, it's a great question. And you're going to be very interested in my next discussion item. But really, what it is that from the Wasm Cloud, Wasm Cloud right now is separated into the host and the runtime. And the runtime deals with everything around executing components, and the host just kind of hands bytes to the runtime and gets back this like wrapped component. So inside of the runtime is where all links to wRPC, all capability implementations take place. And it's why we've started to like why we have like a certain set of built-ins and custom behavior there. So my work, this work is essentially giving the runtime side of things, or sorry, the runtime side of things, giving the host more opportunities to participate in what interfaces are supported, what interfaces are satisfied locally or maybe by a built-in, and what interfaces will go over wRPC. So to answer your question directly, and hopefully this clears it up, this will remain a part of the runtime as something as a facility you can use. It's just when we talk about taking out the wRPC interface implementations, it's more that we'll make them optional, like something that you can provide. When I say you, I mean like the Wasm Cloud host, something that the Wasm Cloud host can turn on or off to when a component says, I want to link to WASI key value. The host now has the ability to say, when you do that, I'm going to call this component, or when you do that, I'm going to go over wRPC, or I don't support that at all and I can't start you. Um, does that, I know I'm just waving basically. I do need a diagram or many of them, but did that answer your question, Masood, around like the purpose?
Partially, but I think for now it's good enough. And because you said the next topic, and I'm waiting for the next topic.
Yeah, fair enough.
I would argue, to answer your question, Masood, that this is very much evolving, on the evolving side, and definitely less so on the taking away, evolving in a way that is modularized, which is, I think, what we all want.
Sorry, I add one comment. Uh, we all know that, let's say, if I have my custom implementation of WASI key value, I cannot basically bypass the wRPC implementation of the interface in the runtime because it's hardwired there. And part of the plan was that we are going to kind of disjoin these things and let more, let's say, flexibility in that regard, and also reduce the kind of the complexity of the runtime by keep adding newer and newer interfaces into it, right? So that my question really was in that regard, that it is part of the core runtime, this functionality, or is part of that optional, uh,
Yeah.
part of the house.
hmm yeah, part of the optional. So the intended design of the runtime now is that the the thing that you get guaranteed from the runtime is WASI 0.2. Like, maybe there's maybe there's a world where it makes sense to be able to override CLI, like standard in, standard out sockets, file system. I would argue that if you wanted to override those, you could virtualize your component in theory. Um, but with the runtime, you get WASI 0.2. Every other interface is something that's satisfied either by an optional, essentially built-in plugin, or your own custom interface. So, or your own custom implementation. So, WASI key value won't be something the runtime gives you um, implicitly. Um, Now in the host, we may turn it on, right? Like it to use it. But same with component to component calls. That would be something that'd be available to you if you decided to have a component call another component for that interface. Cool. Yeah. If folks have any other questions on the component to component call piece? All right. Well, I'm tempted to kick out and just go straight to demo, but since we like literally just talked about like, hey, the next discussion item may interest you, I figure we may as well talk about it and then go from there. So I alluded a little bit that in the current or in Wash right now, the implementation of the runtime is essentially on top of. You all should see my whole screen. Just let me know if you can. In Wash, the implementation of the runtime is like a module in the same or in the CLI, but we're basically just using wasmCloud runtime under the hood. So what is that? What is wasmCloud runtime really? wasmCloud runtime, thanks, good job, GitHub. wasmCloud runtime is basically just slightly wrapped Wasm time. Like when you use the most basic version of the wasmCloud runtime context, you get WASI 0.2. And that's it. You don't get the wRPC polyfilling when you're embedding. You don't get any of the capability implementations. So in Wash, you still have to opt specifically for the interfaces that you add. And that means there's a lot of code in Wash that comes from implementing these interfaces and running the component. Because basically all we're doing in Wasm Cloud Runtime is giving you this nicely kind of wrapped component back that you can make new stores and, call the components exports. So what would really be Wash is a greenfield kind of area. Um, gave some really nice space to work on the component to component calls without being the same core piece that's, well, it is the same core piece that's under the host, but whatever. What I think we what I think we are really deserving of here is basically evolving the wasmCloud runtime forward, so that this, we don't have to have this idea of a custom context component. You don't need to like link in all of your capabilities so granularly, like you're basically just embedding wasm time here, which like at that point, why not just embed wasm time normally? So what I've been working on, you should see my VS Code now, is extracting the pieces of the wasmCloud runtime, which is basically where I started from here, into a crate in the wash repository called runtime. And this is not where it will end up eventually. I'd love to basically release this as a minor version release of wasmCloud runtime, but I'm just iterating on it here to make sure I can get the API surface right. So what this crate does is responsible for a couple of things. Basically, the same core of wasmCloud runtime, which is, hey, please initialize this component. I'm going to give you my bytes that make up my component. So I could have gotten it from the file system or from OCI or whatever. Here's some bytes. Here's some resource limits to apply to the component, like max invocations at a time, -1, all that fun stuff. So the same kind of API service that we have today, with some additional extras. And I won't talk about every extra here, like the volumes, which is a nice way to like abstract the WASI file system, like pre-opens bit. But I want to talk about how this wasmCloud runtime crate would be used. So we can initialize a wasmtime component from the bytes that we get handed in from the request. We create a new linker, all standard wasmtime embedding stuff. We add WASI 0.2. We add WASI HTTP if you have the feature HTTP enabled. We pre-instantiate the component for performance. We hook up the volume mounts, and then we basically give back this workload handle. Now that you'll see the word workload used a lot around this. You'll see the word workload used a lot around this like little host API, but a workload is an attempted evolution of the idea of like a WADM application. So it's a collection of components that make up an individual functionality. I mean, we can call it an application. It doesn't really matter. But from the perspective of what I'm talking about here, a workload is basically a collection of components, and a service is not like a Kubernetes service, like an HTTP ingress service. A service is a component that exports the WASI CLI run function. So a service is a long running component that you can execute, that will like run to completion or maybe run long running and do like a cron job or something like that. So just to set the stage with some of the terminology, workload's a bunch of components. It could have a service in there that runs like CLI, and that's more of an attempt to get to like the long running component world. Nice little overloaded word there. So taking a look at some of the types inside of this runtime crate, I know it's maybe a little confusing. I have the notion of a host. So I think there's some reconciliation to do around the naming here. But when we think about the responsibility of a host, if it's not responsible for starting capability providers like as processes, which is what Luke, the Wasm Cloud maintainer, is working on right now, as basically these endpoints that we can connect to for wRPC. Then the host API, which is what we call today the Wasm Cloud control interface, you can ask the host for a heartbeat. You can request that the host start a workload. So, hey, here's a bunch of components that are organized together. Can you start it? You can ask for the status of an individual workload that you already started based on like the component ID. And then you can stop it. So, like, if we boil down the host API to as minimal as possible, which is essentially the goal here for reducing host responsibility, this ticket that's on the roadmap, is just to have the host be responsible for the lifecycle of components. Um, Download them from OCI, start them, link them together appropriately, and then give me back something that I can use to query its status later or call the component. So the two big pieces that I have in this evolution, like in this wasmCloud runtime crate right now, is the host API. This is just a trait, and the reason why is that the host can be implemented in terms of this crate. In terms of this trait, which is really nice from like a Rust perspective. I can just implement this function heartbeat and then give back the heartbeat, and that's all I need to care about. So what you'll actually do when you run this host, or what will make wasmCloud exist, is wasmCloud will embed this host struct. Sorry, can. I'm not trying to like dictate everything. wasmCloud can embed this host struct, listen for NATS messages, and when you send a request like, "Hey host, can you give me your heartbeat?" or every 30 seconds publish that heartbeat, we'll call this function and hand you back the response. So the host is implemented in terms of this really simple API. We can do unit testing with it without interfacing with NATS at all. Really simple. And I'm sure that there's some that's missing from this, but within the idea of a workload comes all of the information that you would typically get from all of the different, of many different, link this component to this provider, link this component to this component, configure this component to use this. All of it is contained in this one payload, which is kind of like just taking the Wasm application and throwing it at a host and be like, result, run this, please, which is really nice. The host can do validation on this when it first receives the request. It can reject it. If necessary, we can make this annotations hash map a B tree map if we need. Good call out there, Victor. And so it it results in a much nicer way to basically throw all the information at a host that some scheduler has synthesized, and the host can say whether or not it's invalid. You don't start a component and then that's okay, but then the link is invalid because the config didn't exist and yada yada yada. So there's plenty more to iron out here in some of the individual types, just trying to start minimally here. But we can start a workload. And then something that we've been struggling with pretty consistently on the wasmCloud side over the last couple of months is the idea of a built-in. Like, we have these capability providers that you can run separately, implement interfaces, but they come with the cost of every call to that provider is going over RPC, which NATS is very performant, especially for the smaller calls. But if you were implementing like a WASI web GPU capability provider, it would be mega inefficient to send a bunch of like GPU frames or whatever you call them over a network every single time. Same thing with HTTP server, like streaming gigabytes of data. We want that to just essentially call the component directly. And so we've started making HTTP server built in, HTTP client built in, NATS messaging built in. But now we're building that all into the host, and we're doing it at a layer above where it probably should be, which is in the runtime. So we use plugin everywhere. But this plugin in the host runtime, or sorry, this plugin in the runtime crate, you basically think of a built-in provider. Now, this is nice and tradified to try and make it simple. Okay, large bang outside my house. Sorry. This trait is trying to make the built-in provider simple, but make it so that you can embed the wasmCloud host library or runtime library and add your own built-ins really easily. So a couple of functions here, like return the WIT world that this provider will implement all the imports and exports. You get a nice start and stop handler, so you can set up listening on a HTTP address, or shut that down, or persist all your files to disk. And then I called this bind and unbind, but it's just link and delete link. I really would be happy to bike shed over the naming here. But what you get is to participate in the life cycle of linking for the component. So I'll show you what an example of this is with why don't we do HTTP server? So the HTTP server built-in plugin is pretty simple. It implements the WASI HTTP incoming handler interface. Maybe we can make this automatic somehow. You can start it, which an HTTP server plugin has a address. It listens on that address and can, work with HTTP, HTTPS. And whenever a component starts that says, hey, I want to export this WASI HTTP incoming handler interface, the host can call this function and say, hey, this component wants to bind to you, do whatever you need, or tell me that it shouldn't be able to. So as long as it's on WASI HTTP incoming handler, then what we can do is we can set up our rules for host-based routing, path-based routing. We could open up a new address, kind of like how the HTTP server works today. And then we store essentially this handle to the component. And then anytime HTTP requests come in, you can call that component past all the TLS stuff. Come on. You can call that component and handle the HTTP request. So this is for an export. Same thing works for an import. So I can have a runtime config plugin that essentially holds this big old map of configuration for all the components. I can implement this trait for the runtime context. So I basically get this really neat handle to be able to implement new interfaces without the runtime knowing about it. So I can implement get and get all, which is WASI config runtime. And so when a component starts and says, hey, I want to bind to WASI config runtime, um, the wasmCloud runtime doesn't know anything about it. So if this plugin doesn't exist, then that component will just fail to start. But as long as it does, you can add to that specific components like wasm time linker, the WASI config runtime bindings, and implement them here. And then you can, in this example, I store configuration from the interface. We could do it from the component itself. Same for logging, which has no state. You can add WASI logging to the linker and implement it in terms of these like tracing macros. So really, what this means is that at the base level, wasmCloud runtime only does WASI 0.2 and HTTP outgoing, but not incoming. And all of the other capability implementations come from these either built-in plugins, or this is still in progress, working with Luke, we can have a wRPC plugin. So for specific sets of interfaces, the wRPC plugin can say, hey, in my WIT world, I want to take all of the calls to WASI key value, my namespace, my package, what have you, and I want to send them over a wRPC transport. And you can do that. And the runtime doesn't need to know anything about it. So I know that there's maybe a lot here to talk about. I'm happy to answer any questions, or if folks want me to poke around in this more, absolutely happy to. The engine here is really just like wasm time. So the point of the wasmCloud runtime crate is to nicely wrap wasm time, enforce resource limits, and give you hooks to extend the interfaces that you want components that run on that runtime to support, in such a way that isn't just like straight up giving you callbacks. It can be extended in a consistent way for multiple plugins. So wasmCloud would embed this, and basically all the capability implementations that we have right now in wasmCloud runtime would just be like shifted over to this plugin layer, which you can turn on and off, start the host with or without. Um, and yeah, so sorry, Mr. Your hand is up and I keep trying to wrap up. Really, all it is to say is that this doesn't really change too much about functionally what happens when you run wasmCloud, but what it does give us is a lot of ability to customize what happens when a component calls an import or when we're calling a component to either do a built-in, to send it over wRPC, to call this other component, things like that, which is exactly what I need in Wash. And if we can agree on a really small host API, then exactly what we can do in Wasm Cloud. Yeah, Masood.
So I just wanted to kind of put something out there. And if what happens if we expose the Wasm time store to components? The reason that I'm saying this is that, if you look at the capability provider, for the most part, the reason that the capability provider is a long-running process is that it needs instantiation or initialization connecting to some source or whatnot, as well as keeping a state in terms of the consumers or the components that are its clients, right? So if it if we externalize that store, that not to be part of the provider, we're opening up the potential opportunity that a provider doesn't need to be a long-running process anymore and could be a component that only is instantiated when there is an incoming call, right? But right now, every provider has to maintain its own store, right? And that's why I thought that as part of this evolution, maybe that would be a good idea that we also expose that store and provide the facilities that providers can leverage that. And again, there could be situations that because the initialization is a long running or expensive, let's say, and a provider has to be a long running process. But in a lot of cases, that's not the case. And that means that we can save on resources and also, kind of converge on that idea that providers are also components and can leverage every benefit that you're introducing in the ecosystem of Wasm Cloud in regards to the components in process calls and whatnot. And if a provider is just a wRPC remote server, that would be responsible for, providing all that is needed to run. But within the ecosystem itself, it might be beneficial. And it seems that Bailey agrees with me.
You get it. That's the big idea here is essentially both with the service type workload, which would be is like intentionally tagging it out as this is long running or could potentially be long running. The other version here is this workload type, this component, its lifetime is tied to the store, right? So there is some lifetime trickiness to do here. But with WASI P3, we get async reentrancy, which was really the big feature that we needed to be able to have components act as these capability providers. So with WASI P3, yeah, we could have scale to zero capability providers that are sandboxed as components, which is pretty cool.
Yeah, I think that's definitely an explicit goal of this is it, if you know what the life cycle requirements are of your component, your provider, does it need to have a consistently open socket? Does it need to persist something to disk? Does it need to have no state at all? I'm trying to think of an example of this because like the messaging provider and like S3 and all that stuff, like we have so many providers that open up connections and then basically hold on to it. But if you have a provider like um, WASI logging here, this WASI logging provider doesn't need to like built in basically, it doesn't need any state. It's just whenever you call it, we need to emit a tracing event, right? And same thing, well, not same thing, but similar idea with the blob store file system component. Like this component implements WASI blob store. It does need some state, and it uses WASI file system as the facility there. So there's a lot more options here where you can decide if your provider is stateless and doesn't need to be long running, then maybe you could run it as a component or as a wRPC endpoint is also fine if you wanted to scale it in totally independently. Um, or like Bailey said, in wasmCloud right now, we really have no concept of running something as a CLI. Like it doesn't really make sense. We don't have a facility like because you initialize it and then you're basically waiting for this incoming HTTP or message or trigger or whatever. So having some way in the runtime to execute a long running component gives you some options of like if you can hand that component a socket or a file descriptor to do long streaming to or you know whatever. That's something that could make sense, and you could implement. I mean, yeah, I think you're still here. Like, that's the whole weird thing with like the cron capability provider. It's like, okay, so now we have this whole other process to just like parse a cron statement and then sleep before calling the component. That's something that could totally just be a component that's sitting there idle. So I hope we can use I hope we have a lot more control over that soon. So yeah, I mean, hey, uh, anybody have any fun questions? I know this is like a fire hose of information and me just ranting at you as I point towards my editor. So my apologies, I'm not getting a diagram together. But does anybody have anything they wanted me to look a little bit further into? We got a couple minutes, and I think Bailey, how long do you need for your demo, or how long want?
Yeah, it's pretty short. This is why I like to demo before you, Brooks, because you're like, check out this amazing evolution of wasmCloud. It is a new way to run our workloads. I've got a demo that's so fast. I think I could do it in 1 minute. You
Well,
want to
maybe
see it?
does anybody have any questions? Speak now or forever hold your peace. Cool. Really just to wrap that up, you can go see the component to component calls in Wash now, like in the Wash repo now. On the runtime side, I'm still fiddling with traits and types and naming and all that stuff, but I should have a PR up for that into the Wash repo. Um, later this week. And really, the goal of having it in the Wash repo is so that I can iterate really quickly. But I want Wash and that the wasmCloud runtime crate to just like flow back into the wasmCloud mono repo. So just been trying to make sure that I can like have a sandbox to iterate this on this as quick as possible. Um, but yeah, okay. That was just a Sorry to break up that flow again. I just wanted to wrap up the thoughts, and if anybody was interested in seeing this code, where it may be. Um, Bailey, thank you for doing the demo since I wimped out.
That was weirdly a wimp out. We're at 154. Brooks is like, look at all these cool things I made. So in the same project that Brooks was showing things off, we have some little nice enhancements because I feel like Brooks has gotten really far on where Wash, the next version of Wash, should be, the next shape of it. And so I've been trying it out myself with all my normal like workflows, and I've been dropping issues, giving little feedback, smoothing out rough edges and that kind of thing. And this was one of the first things that I really wanted. So I added, AKA via Clap, which is the CLI crate that we use. Clap supports auto-completion. There's an autocomplete crate. I added that, and guess what? It just worked. So it was a really easy thing to get done in like 10 minutes, and I spent more time trying to figure out all the different ways that people load shell completions. Turns out there's lots of stuff there, and so give me feedback on this if this looked good. I tried to find that in the community. It took more time to do this part than it did to add the completions themselves, but I just followed these steps. So let me show you what it looks like. If I say wash and then I have an N and I hit tab, it will tab out to wash new. Maybe. Oh, let me open up a new tab. Make sure I just cleared everything out and installed the latest. Wash new. It auto-completed new. Look at that, people. And when I hit that and I say, let's use Rust, I'm going to use the sample WASI HTTP Rust. Go ahead and create it for me. Cool. Created it. I'm going to go in here. Now I have a really simple, basic Rust project. So let me just try to build it. I hit B and I tapped. Woo, completions. It's not that amazing, but look at the really nice experience that you get with the new version of Wash. It is really nice. So I was able to quickly build this thing. Now there was one little bug that we got fixed and published in the last release. Brooks, I did that while you were talking. And now you see that we've got like a very minimal config file with our latest fixes. We had some extra stuff in here. That's gone. Just little simple bugs like that. So the more we get people using this and giving us feedback, I think the better. And one other thing, like where you actually probably will want some completions is if you type out OCI and you can't remember if you want to push or pull. Hey, there's that command completion there. That's the only one that I can think of that like has two commands off of it. So that's a pretty weak sauce demo. But the parts that are cool is how fast we're able to iterate on top of this next version of Wash, get changes in, and we will cut a new release as soon as your changes land, basically. So yeah, I think that's the quick TLDR. Do you want to talk about this part or you want to save that for another meeting? We got 3 minutes.
Maybe another meeting, but I do have a question.
Okay.
So, um, Bailey, will you just run wash, just like no args? Okay. I didn't know if you had any plugins installed.
I
Um,
do, I think. Maybe not anymore. I deleted my wash folder. It does actually include it in the completions. I tested that. That's what you're asking for, right? Yes, it does
yeah,
work.
yeah, I
But
was wondering if
I cleared that out because I didn't want people to see my super secret plugin that I'm working on.
I the secret. Okay. Yeah, that's what I was wondering. Like if you install a plugin, like um
This one
yeah,
looks
that one.
good. Have
Yeah,
you published this one or do I need to build it?
you gotta build it. But it's Rust, right? It'll build super fast. Yeah, I was wondering if you had like if you registered a top level command like my super cool plugin, if you could do wash my and then hit tab, if that would pop out.
It does work. All right, yeah, let's test this on the fly, right?
It's so
Okay,
fast.
so I just did that. I'm gonna take this and put it right here. Oh, yeah, also, hey, I added this little note. Hey friend, make sure that you regenerate your plugin. So hang on. Uh, completion. Boop, 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 doo, doo. I'm just gonna make sure my doc is good. Wash completion. Hey you, go back here. Rerun this. Here. Wash. Completions work. Wash without commands. I've got a completion, and look at that! It's got the wash inspect. So if I type wash inspect, oh, it doesn't have any commands off of it though.
Like, so if you do wash inspect dash and then hit
Well, if I say wash I, it auto completes it, right? And if I say you said dash like this, oh
oh
yeah,
yeah. So
there it
so
is.
wow. So yeah, that
So
inspect plugin, I changed the top level name to like inspect enhanced or inspect plugin or something, because it would conflict with the other one if you didn't. So cool.
yeah, so that's nice. Thank you, Brooks.
That's awesome, Bailey. Thank you. Um, that completions is super super nice for like I don't know. Like I forget the ordering of some commands sometimes, which is probably bad. But you type it out and then you can get the yeah, it's pretty cool.
Easy peasy. And we've dropped in other bug fixes, but we're not, I don't think we're quite ready for 1.0, but we are getting really close. So this is definitely the community's call to action to come in here and try it out, give us some feedback.
You know, ran right up to the end. Well, thanks so much. This was a pretty exciting community meeting, pretty exciting progress on the Q3 roadmap. We're moving a lot of things across. Honestly, two of the other things that are in triage still are intentional distributed networking and simplifying interface maintenance. So we'll probably run it right up to the end like every roadmap, but it's looking pretty good, making good progress. Um, Folks, as always, if you're looking for an opportunity to contribute or pick something up that's a little more meaty, please let me or one of the maintainers know. And um, other than that, download Wash, start playing with it. You have to. It's actually required since you're all here. You agreed to it. Um,
It's also actually really nice. I definitely prefer it.
Heck yeah, it's nice. All right, y'all. Thank you so much. We will see you next week for your favorite meeting of the week, Welcome Cloud Wednesday. So, uh, have a WASM Cloud day, everybody.